So we're going to do the 2-2 at-home practice problems now. So obviously all of these say, please graph the following on graphs provided using the slope-intercept formula. So we're going to graph these equations using the slope-intercept form of the line. And specifically on the test, you're going to have to provide the slope and you're going to have to provide the y-intercept. So let's take a look at this first one, y equals 2/5 x minus 3. So this first y equals 2/5 x minus 3 is already in slope-intercept form. So what we do, slope-intercept form, remember, is y equals mx plus b. We already have that. So all I have to do, now that I have y equals a number times x plus another number, is say the slope is the number 2/5, the coefficient of the x term. The y-intercept, well, the y-intercept, remember, is a point, and specifically it's the point 0, comma, -3. The y-intercept always has 0 as the x value, and the y value, when I'm given slope-intercept form, is this constant number here. And obviously, since we have a -3, the y-intercept has a y value of -3. So once you know the slope and the y-intercept, then you can go ahead and graph the line. So we go here, graph the line. We start with the y-intercept. Let's go a little bit thicker on this. Let's graph it in blue. Yeah, let's go blue. 0, -3. Remember, 0, -3 is this point right here, roughly, if I can get my cursor on it. And then that might be a little too thick. Let me redo that. There we go. So 0, -3, right about there. And then a slope of 2/5. Now, again, slope of 2/5. Remember, on a slope, the top number is the change in y, the bottom number is the change in x. So that's a +2 over a +5. That means that when I go here, I'm going to go up 2 units, and then to the right, 5 units. So if I've done that right, up 2 over 5. I can also go another up 2 over 5 if I like, and that would be my next point. So this is the pattern I get. Now, the other thing you can notice about these slopes is that obviously this fraction is equivalent to the other fraction that we've dealt with, -2 over -5. Well, let me put the negative, right? Positive over positive is the same thing as negative over negative. So if you would have if you needed another point that you could have done, you could have gone down 2 and to the left 5. I think that's it right there. Okay, so you get that pattern. And then obviously, when you're dealing with, oh, do I have another? When you're dealing with drawing a line, go ahead and draw that line. Let me go a little less thick. This is, whoops. Oh, man. I didn't draw that very well. Let me see if I can get my lines a little bit better. Yeah, line there. And then I'll take my brush and kind of paint it in. So this is the line here. Again, ignore the different colors. I'm not sure how to get different colors, but that's the line y equals 2/5 x minus 3. Now the next problem that we have is 7y minus 21 is equal to negative 2x. When I go to deal with that one, basically this is not in slope-intercept form, so I'm going to make it in slope-intercept form. The first step that I do there is I add 21 to both sides. If I add 21 to the left-hand side, I'm just going to have 7y remaining on the left. If I add 21 to the right-hand side, well, whoops, 21 and negative 2x are not like terms, so we end up with minus 2x plus 21 on the right-hand side. This isn't quite in slope-intercept form yet. I have to divide both the left and the right-hand side by 7. If I divide the left-hand side by 7, I just end up with y. If I divide the right-hand side by 7, I have to divide both pieces. The negative 2x, I have to divide that by 7. Negative 2x over 7 becomes negative 2/7 x. And then if I divide that 21 by a 7, I end up with a 3. So that means that the slope of this line is negative 2/7, and the y-intercept of this line is the point 0.03. Okay, so there we go. So negative 2/7, again, I'm going to think of that as a negative 2 over a positive 7, or you can also think of this as a 2 over a negative 7. All right, so either go down 2 to the right 7 or go up 2 to the left 7. But we're all going to start at 0, 3. So let's start at 0, 3 with the line that I said. So 0, 3 is there. Go down 2. Again, that's a negative 2, negative in the y direction. And then to the right 7. There goes 7 there. Yep. You could also again said up 2 to the left 7. And there you go. So that is what we get. What do we draw our line here? And then to finish this off, remember you draw those arrows at the end of the line to signify that that pattern goes on forever. Whoops, that's bad. That's okay. Can't get my cursor to work today. All right. So there you go. That is the graph of the line 7y minus 21 equals negative 2x. Is y equals negative 2x. Now this is in slope-intercept form already, although it doesn't quite look as like y equals mx plus b. You can think of it as y equals mx plus b in that you can think of this as negative 2x plus 0, right? So it does have the form that we want it to have. That means that the slope here is negative 2. You can write negative 2. You can think of it as negative 2 over 1 if you'd like. That's probably easier to think of the slope that way. And obviously the y-intercept is the point 0, 0, which is the origin. So that's what we get. Slope is negative 2, or think of it as negative 2 over 1. When you write this on the test, you can just write negative 2 and stop there. and then the y-intercept is the point 0, 0. So when you go to graph this line, we're going to start at 0, 0, down 2 over 1, down 2 over 1, down 2 over 1. You can continue that pattern. If you want to go in the opposite direction, you know how to do that already. So, and then obviously we can draw a line here through these points. Draw a pretty good line as far as I can do anyways. And then as far as arrows on the end, we'll draw a little bit of arrow on the end to signify that this line goes forever in either direction. And so there you go. That's how to graph lines which are in slope-intercept form, or like we did in number 2, graph lines which aren't in slope-intercept form, but can be made to be in slope-intercept form. Now, on questions 4 and 5, those are slightly different because on question 4 and question 5, we only have one variable. Now, I like using the other method, the table method, for doing these instead of trying to put them in slope-intercept formula, because quite frankly, if you only have one variable, it's really hard to see the slope-intercept form. In fact, in number 5, it's impossible. So when you go to a question like y equals 1 or x equals -5, what you're going to do is, what I like to do is I like to think of, let's just go to y equals 1. Now this one could be put into slope-intercept form, but it's not really worth it. What I like to do is say, well, what kind of points could exist here? So let's think of inserting a table just like we did before with x values and y values. So let me go something like this. Let's take an x value and a y value. Well, if I start putting in x values like 2, 1, maybe 0, maybe -2, what's the y value have to be? Well, the y value has to always be 1 because it always says it's going to be 1. So what we have here is we have a bunch of points, 2, 1, 1, 1. I'm going to whoops, that's okay. So I apologize for that. So 2, 1, 1, 1, 0, 1, and -2, 1. Notice that everything has 1s as y values, and the x value can essentially be anything we want. So when we go to graph this, as far as points go, let me graph this one in red. We go 2, 1, 1, 1, 0, 1, -2, 1. Notice that I'm getting horizontal. These points are forming a horizontal line. I didn't do it perfectly because I was trying to do it quickly, but I'm getting a horizontal line, and the y values for every point are 1. Okay, so my line looks like that. Obviously, as always, I'm going to draw the arrow. Trying to draw that arrow. Yeah, it didn't look very well. Arrows at the end. Doesn't matter how you draw your arrows at the end, but the point is that the pattern goes on forever. So that is the graph of y equals 1 in 2 dimensions. As far as the graph of number 5 is x equals -5. So we don't want to go x equals -5. And in a similar way, no matter what we plug in for y, if I plug in 4 for y, if I plug in -3 for y, if I plug in 0 for y, if I plug in 2 for y, the x value always has to be -5. So I get a lot of points. All of them have x value -5 and different y values. So when you go to graph that, now I forgot what I plugged in, but x value -5, so 0. Excuse me, -5, 0, 4, so -5, 4, -5, 2, -5, -3. Basically, we're getting this vertical line. Again, I forgot what points I just used. -5, 4, -5, -3, -5, 0, -5, 2. Let me think. -5, 4, -5, 2, -5, 0, -5, -3. I missed this one. All right, so we're getting this vertical line, and we get this graph. Again, I'm not very good with the cursor, so the better you are with the cursor, the easier this is gonna, excuse me, the better, yeah, you are with the cursor, the better you are drawing, the easier this is gonna be. Okay, so the line x equals -5 looks like that. All right, and that is the at-home practice problems for section 2.2.